Okay. Is it still morning time? It is. Good morning, Abyssers. Hopefully you're up, had your cup of coffee, your tea, your latte. Hope you're ready to do some math. All right. So did I tell you this? I'm going to make this a little bit bigger. That's the equation of a circle. Okay? And the circle looks like this. Well, I think this was Allie. Allie gave me a little bit of insight. Thank you, Allie. Wasn't you? Really? You sure? It's the asthma. That I think it's the asthma medication that just causes you to blurt stuff out. Didn't I do this, Allie, and you said you didn't want to do this? Didn't I make it implicit by doing this? Maybe it wasn't you. It was you?
Yeah.
Where I said plus or minus the square root of 25 minus x squared. And I said, would you like to take the derivative of that? And you said, no. That inspired me. I wouldn't either. You know why? Because implicitly, let's say there's a point here. I think the point 3, 4 works in here. If I got 3 squared, that's 9. If I have 4 squared, that's 16. 9 plus 16 is equal to 25, correct? So there's a tangent line, Justin, that goes, if I can draw it, goes right there. Okay? So I'm going to do implicit differentiation. Now, can you see that okay, Justin, or is it a little bit tough? Is that better? Okay? And so it's up to you. But when I use implicit differentiation with respect to x, that means everything's going to be over dx. And I take the derivative of every variable. So if you wanted to, I take this x squared and I just take the derivative, just like I normally do. I always get 2x. But in reality, Caitlin, that's 2x times dx over dx. Because I took a derivative of a variable. And that tells me how much is changing with respect to x. Plus, then I come to this y squared. And I use the same technique, Elijah. So which is, there's a leading coefficient of 1. 2 times 1 is 2. Then I get y the first. But because that's a variable, that's going to be dy dx. And then I have my old constant. And anytime I take a derivative of a constant, it's just gone. Now it's too big, isn't it?
Is your mic on, by the way?
Yes, it is. Thank you, thank you, thank you. You have earned 1,000 mental extra credit points. Have you earned any other before? You only have 9,000 to go. That's better than Delta. Because you mean you need 1.5 billion points to be able to fly 10 miles in Delta. I just made that up. Actually, you don't need that much. Does this make sense to everybody? Okay, now, do you have to write dx over dx? No. It's the same as 1. So it's up to you. Some people do, because then that gets them to remind. I had people that did it all the way through May and got it correct, because then they didn't forget to multiply y by dy dx. Because that was an easy thing to forget to do. So you have to decide how you want to do that. You want to make sure you have your dy dx's. So this is going to become 2x plus 2y dy dx equals 0. So that means dy dx is equal to a negative 2x over 2y. Does that make sense how I algebraically got that? I subtract the 2x and then I divide it by the 2y. So that means dy dx is equal to a negative x over y. Now, what is this? This is the derivative. What is its purpose? To give me the slope of a tangent line, correct? But rather than just the x-coordinate, I also need the y-coordinate. Isn't this really a lot simpler, Allison, than what if you were to try to use this? Do you see how slick it is? So what do I need here? Well, x is 3, y is 4, so the slope of my tangent line is a negative 3/4. Boom! I'm done. Are we doing okay on that? Alexis, you ready for going to number 4?
Sure.
Will you read that to me?
X, Y.
What do you mean x, y? What are x and y?
Times Y.
Say it again.
X times Y.
Say it again.
X times Y.
Have you given me the product rule in Vietnamese yet?
No, not yet.
Okay, I have it in Somali and I need to make a poster. Okay? Product rule, right? And I'm going to put up here, don't forget the product rule. And then I'm going to put a big X there because X we think means times, even though it doesn't here. Maybe I'll put a big dot. Okay? So, we have to do the product rule because you said times. There's going to be a plus here. Would you agree? So what are you going to do on this left side? What do you want to take the derivative of first? Do you want to take the derivative of x or do you want to take the derivative of y? X. What is the derivative of x? 1. Or dx over dx. Would you agree? Which do you want me to write? 1 or dx over dx? 1 times y. Correct? Now we're coming over here. You already took the derivative of x, so x is going to be okay, times the derivative of y. What's the derivative of y? dy over dx. You're doing fantastic. And what is it going to equal?
0.
0. See, it's tricky because 1 is a constant. And if you take the derivative of a constant, it becomes 0. So that means dy over dx is equal to what?
That would be negative y divided by x.
Negative y divided by x, which is the reciprocal of this one, right? It's like there's a relationship between this one and this one. And there is. I've seen the proof with straws. Okay. Caitlin, I like the right side of the room. I know it's your left side, but it's my right side, okay? Now, there are 1, 2, 3, 4, 5 terms. You get to choose one of them, and you're going to compute the derivative of them for me. Okay, I'm going to make this a little bit bigger, and then when Aiden will tell me when I have it too big. Okay? It's fine now, right? Do you normally wear glasses?
That's kind of like 50-50. I wear glasses.
Did you wear glasses yesterday? Okay. So it's just me not just being weird. It actually happened. Okay. All right, so which one of these are you going to take the derivative of, Caitlin?
Do the y to the 4th.
You're going to do y to the 4th. You're going to do the first one. Do you feel confident in it?
Yes.
Okay, tell me what it is.
4y to the 3rd.
Is that it? Is there, pardon?
For that simultaneous.
No,
No.
you forgot something. You're taking the derivative, so what has to be with it?
Oh, would it be dy over dx?
dy over dx.
Yeah.
See? That's the tricky part of implicit differentiation. Because you imagine trying to get y by yourself on this thing. It's insane, right? Denise, you only have 1, 2, 3, 4 terms left. Which one do you want to take the derivative of?
Let's do y to the 3rd.
Y the 3rd. So it's going to be a plus. What do you think it is?
3y to the 2nd dy over dx.
Perfect. Okay, all right, picked up. So Aiden, there are only 3 terms left. Which one do you want?
The derivative of 17 is 0.
Yep, I'm surprised people don't take that as the first one. It's like, it's too easy. We're polite. I'm going to leave that humongous piece of pie for somebody else. Not me. Justin, there are only 2 left. Which ones do you want?
Take the derivative of 3y.
What are you going to get?
3 dy, negative 3 dy dx.
Perfect. Ryan, there's only 1 left.
Negative 25 x to the 4th dx over dx.
You want me to write dx over dx? But there would be, wouldn't it? Except I didn't give myself enough room. So I'm not going to put it in there. Okay? Elijah. There's a problem here. I have 1, 2, 3 terms with dy dx in them, and I only want 1 dy dx all by itself. How do you propose that I fix that?
Can you do like 4y third plus 3y squared minus 3 parentheses times 2x?
Can I scoot this baby over here? Notice this term has no dy dx in it. Can I scoot it out of there?
Yeah.
You know, move it to the other side. I always do that. And then you said factor out the dy dx.
Yeah.
And then I have 4y cubed plus 3y squared minus 3. It looks like that. And so the formula that computes the slope of the tangent line would have 25x to the 4th in there. Would you agree with that, Elijah?
Yes.
And then I would divide by this quantity. And so on the bottom I would have 4y cubed plus 3y squared minus 3. And the purpose of that thing is to find the slope, and I would need to know x and I would need to know y, correct? Guaranteed this question's on the AP exam being able to do that. Sometimes what they do is they say the derivative of this is this, show that you can get this as the answer, and it'll be worth 3 points. Does that make sense to everybody? Owen. I want to know the slope of the tangent line. Which side do you want to do? The left side or the right side?
Left side.
The left side. Okay. This thing is huge, so I'm going to make it a little bit smaller, but you have the piece of paper in front of you, right? So tell me what the derivative is on the left side. I'm moving way over here to the left because I did not give myself a lot of room last period. As our viewers responded, they said, you scrunch things in and you got terrible handwriting, and start doing a better job. And then Rosie barked. Okay? So tell me what to write here.
So 12 times the quantity of x to the 3rd plus y squared, and then squared times 3x squared.
And there would be a dx over dx here, correct? But do you want me to write it or no? Okay, I'm good.
And then
Did you hear that? I'm good.
Better.
Plus?
Plus 2y, and then dy over dx.
Equals, correct?
Yeah.
Okay, Jack. Will you read that for me? What's on that right side? Right here?
Just read it.
Yeah, just read it.
Negative 54 times x times y.
Yeah, negative 54. You could even said a negative 54x times y. But you're right, it's a negative 54 times x times y. There's no plus, there's no subtraction, there's no division. There's just a product, hence the product rule. Okay? So, I got to have a plus here, correct?
Yeah.
What are you going to take the derivative of first? The negative 54x or the y?
-54x.
Okay, what's the derivative of negative 54x? Right, in reality it's a negative 54 dx dx, correct? See, when I say that, that's out there in the abyss. But you don't have to write dx over dx because that's 1. So it's going to be a negative 54 times y. Would you agree with that?
Yeah.
Now you've already multiplied figured out the derivative of a negative 54x. What's the derivative of y?
Y times dy.
No, because this is y to the 0, y to the first, correct? And so if I do that, I'm going to have 1y to the 0, aren't I?
Yeah.
Times, you're right. Can I write it like that? Is 1 times dy dx dy dx? Ty. I got a headache. Actually, I don't. Wait, this could cry. This is the problem that I told you. Carr says, look at how much work I said, you wait till this class gets to this problem. Do you see the dy dx over here? You see the dy dx over here? What am I going to do now? Yeah, how do you go about that? It doesn't look simple. You want me to give you a hint? Okay. This is what goes on in my brain. Okay? So, right here, I'm looking at this. This isn't so bad, right? But this is bad. So what I do, this is how I view it. I wonder how I best should describe this. I've got this. Something. And it's icky. But I could call it icky box. Right? And inside here, I got two things. Not too bad. And not so good. If you would have seen this, and I asked you to get rid of the parentheses, how would you do it?
Multiply.
Yeah, you would have distributed them, correct?
Yeah.
Well, you're going to have to distribute icky times not so bad. And then you're going to have to distribute icky times not so good. Okay? So what I do in my brain, I try to come up with another picture. Because I get caught up in all this garbage. And Caitlin, they give you this crazy thing. I don't want to multiply that out. And if I don't have to, I don't. Because I know I'm going to plug a negative 1 in for x and 2 in for y. I'm going to come up with a number. All right? All right, Ty? So, I got 12 times 3. They're coefficients. What does that give me? 36. I like 36. It's divisible by 3. X squared. Would you agree? Parentheses. X cubed plus y squared squared. Plus. So I took icky times not so bad. And we got this. Ty, did I make any mistakes? Because this thing is so crazy, I'm worried about making a mistake. Okay, that look okay? Plus, now I'm going to take icky times not so good. And I got a coefficient of 12, a coefficient of 2, that's 24, and then I got y. Would you agree?
Yep.
And then I got parentheses x cubed plus y squared squared times dy dx. Okay, because my end game is this term, this is all one complete term, right? It would have been, Jack would say it's 24 times y times this quantity times dy dx. Even though it's a whole bunch, it's like a knot, right? You can have a nice simple knot, or you could have a great big ball knot, right? Where you say, who had this thing last? Well, I'm going to want to get this with the other dy. I want to get these two together on one side of the equation and these two together on the other side of the equation. And then I'm going to factor out the dy dx, which is what Elijah kind of said, hey, we got to do, right? All right, so I'm going to have a negative 54y minus 54x dy dx. So now what I'm going to have is I'm going to have 54x dy dx plus 24y times this god-awful thing, and why did Kruger come up with that, dy dx, equals, I still have this negative 54y on this side, but now I'm going to have a minus 36x squared, parentheses, x cubed plus y squared squared. I hope I didn't screw up anywhere. Aiden, you would tell me if I did, right?
Yep.
Ty, look okay? Okay, so Ty, what am I going to do now?
Factor out dy dx.
Yep, and I'm going to divide all in one swoop because I'm getting tired. Okay, so I got dy over dx, and this is going to give me a rational craziness. And on top here, I got negative 54y minus 36x squared times x cubed plus y squared squared over 54x plus 24y parentheses x cubed plus y squared squared. Okay. Now, I know you guys got calculators. I'm putting mine away. I always do it in my head. Why do I do it in my head, Denise? Because I figure every time, the longer I teach math, the longer I do math, the more I can do arithmetic in my head, the less likely I'm going to have Alzheimer's. I really believe that. And I don't want it to be a problem for my kids. They're going to have some big decisions. They're going to have to come up to me eventually and say, Dad, we got to take the keys away from you. Dad, we're going to move you out of your home. That's going to happen someday. I want to be able to mentally talk to them and say, okay. All right, so that's why I do this. So I'm going to put a negative, I'm going to put 2 in for y, so I have a negative 108 minus, if I put a negative 1 in squared, I got a minus 36, right? Because that's going to be 1. And in here, what am I going to have here? I'm going to have a negative 1 times 2 squared, which is 4. That's 3. 3 squared, I'm going to have 9 here. Does that look okay? Did everybody see where I got 9? Over 54 times negative 1 is a negative 54 plus 48 I already know that's 9. Equals. All right, 36 times 9. 36 times 9. 36 times 9 is 324. A negative 108 minus 324 is a negative 432. I hope somebody's checking my work. This one, 48 times 9 is 432. 432 minus 54 is 300. What did I say? 432 minus 54. 270. 272? 274? Isn't this 432? Isn't that right? 48 times 9, is that 48 times 9, is that 432? Minus 54. Is it 374? 378. Shoot it. That's not too bad. And if I simplify that, I think you get a negative 8/7. Am I right? So the slope of my tangent line is a negative 8/7. That's a lot of work. Yeah, I'd never give you a quiz problem like that. The whole idea is I want you to see you got to, I didn't want you to think that you got to multiply that out, because if you did, can you see the trap it creates? It's bad. So I had to think of it like this.
You can't see what you're pointing
I had to think of it like this. All right, this one's not so bad. Landry, you see this one right here? We're finding the equation of the tangent line. What two things do we need? Point. Slope. Let me stand up. Be right back. My markers are disappearing. "13 times this year." I've said we've had the correct answer. All right, we have a point. That is like a gimme, right? All right, so let's figure out, we got to figure out how to get the slope. So tell me what I'm going to do here.
Well, first we find the derivative.
Yeah, what's the derivative?
3x squared.
And you could write dx over dx, correct? Okay. Plus,
Plus 8y dy over dx.
yeah, this is kind of a sad moment, so I'm just going to pause. What are we going to get over here?
0.
My 3 is gone. Okay. So what is dy dx equal to?
Is it negative 3x squared divided by 8y?
Yep, and we're plugging negative 1, 1 into there. What does that give me? If I plug a negative 1 in for x and 1 in for y,
You get negative 3/8.
negative 3/8. This is very typical AP problem. This is far more reasonable, wouldn't you agree? And so the equation of our tangent line is what?
Negative 3/8 f times parentheses x plus 1 plus 1.
Plus 1. And what, this is my check, and I don't know if maybe I've repeated this. If I put a negative 1 in here, do I get a y that's 1? I do. That's how I always check. I should get this value. Because remember, this equation and this tangent line touch at that point. That's the point of intersection. And I should be able to put a -1 into here and 1 into here and get 3 as an answer, and I do. Does that make sense to everybody? That is a fundamental problem. Do you see how the slope, the equation of the tangent line has moved? We've used it every single time, and our derivative process is getting a little bit more complicated, correct? But you still need to know the power rule. You still need to know the product rule. You'll still need to know the quotient rule. You'll still need to use the chain rule. Okay? It's like, okay, now we feel comfortable. We're going to add something to it. Okay? We cool on that? All right, I am done talking. And